This is the second video about hyperbolas. In the first video, I described the differences between the vertical and the horizontal hyperbolas. In this video, we're going to go through two different examples so that you can see exactly what happens in each example. So if we take a look at our equation here, we have x minus 1 quantity squared over 4 minus y minus 3 quantity squared over 4 is equal to 1. If this was a plus sign in the middle of these two fractions and the denominators were the same, this would be a circle. However, since the negative is here, that means that this is a hyperbola. So I know that this hyperbola here, since the x fraction is positive, I know that this is going to open left to right. So that means I'm going to open left, right. Another thing that I also know without doing a whole heck of a lot of work is I can see that my center is going to be 1, 3. So let's begin to plot this. So if I plot 1, 3, 1, 3 is here. So this is going to be 1, 3. So now at this point, I'm going to take the square root of 4, which is equal to 2. And so I'm going to count 2 over in the x direction and plot a point. 1, 2. And I'm going to plot a point. 1, 2. And I'm going to plot a point. And these, because the x fraction is positive, these represent my vertices. So if we take a look at this, this vertice is negative 1, 3. So we have vertice is negative 1, 3. And then my other vertice is going to be 3, 3. Next, I'm going to look at the y fraction. So the y fraction is 4, so the square root of 4 is 2. So I'm going to take my center and I'm going to count up 2 and I'm going to plot a point, and I'm going to count down 2 and I'm going to plot a point. Now, these points represent the midpoints of my rectangle. So I am going to draw a rectangle at this point. Then I'm going to take my ruler and I'm going to draw my diagonals. I'm just going to take this out for a little bit. Make sure I connect these. And these are going to be my asymptotes. Now from here, I can actually graph my hyperbola. So my hyperbola is going to go right along these boundaries. This is one of the reasons why we have to create these asymptotes, so we can see exactly where our hyperbola is, how wide it is, or how narrow it is. So this is my hyperbola. And so if we had to graph it, and that would be it, this would be the end of the problem. But I want you to find a whole bunch of different other things too. So let's talk about the transverse axis. The transverse axis connects the vertices. The transverse axis connects the vertices. Let me straighten that out. So the transverse axis is going to be, since we go left to right, this is going to be the x-axis. The conjugate axis is the other axis, which is going to be here. And this is going to be your y. Now we're going to calculate our foci. So our foci, the way we calculate that would be c squared is equal to a squared plus b squared. Make sure you can still see that. And so we are going to end up having 4 plus 4, which equals 8. And so c squared equals 8. So c is going to equal the square root of 8. which is equal to the square root of 4 times the square root of 2. And so this is going to be equal to 2 radical 2. So that's my C value, is 2 radical 2. And so my foci, in order to figure out my foci, which they are, as you can recall, someplace over and through here, my foci is going to be 1 plus 2 radical 2, 3, and 1 minus 2 radical 2, 3. Because you can see the movement is left to right, so that means that we are adding to and from the x value of the center while leaving the y value the same. So now let's go after our asymptotes. So when doing your asymptotes, I think it's really important to understand what point slope form is. So point slope form is going to be y minus y1 is equal to, and this time we're going to have plus or minus your slope times x minus x1. The reason why we have plus or minus is because we have two asymptotes. We've got this having a positive slope and this one having a negative slope. So the point that is common to both asymptotes is the center. That's the point that they have in common. So that's the point that we're going to use in our point slope form. So our center is 1, 3. So I'm going to plug this in for my x1, and I'm going to plug the 3 in for my y1. So we have y minus 3 is equal to plus or minus our slope times x minus 1. So now we have to go after our slope. And slope, if you can recall, slope is equal to your rise over your run, or your change in y over the change in x. Well, the rise is going to be 2, and the run is also going to be 2. So here, this is going to be 2 over 2, which is equal to 1. So my asymptote equations are y minus 3 is equal to plus or minus 1 times x minus 1. So these are going to be the equations of my asymptotes. And if you were actually to do this in y equals mx plus b form and say y minus 3 is equal to 1 multiplied by x minus 1, and then y minus 3 is equal to negative 1 multiplied by x minus 1, you would get these in point slope, or I'm sorry, these in y-intercept form. So this is y equals, you'll get x plus 2, and then you'll get y is equal to negative x plus 4 if you were actually to separate these out and do them. So if you look, y equals x plus 2, x, so we have 1 is the slope, right? So 1 is the slope, it's positive, and it says it's going to have a y-intercept of 2. So look at where it crosses. It crosses exactly at 2. This one is y is equal to negative x, which is this, right? Plus 4, and look where this one crosses. It crosses right there at 4. So this would be everything that you would need to know with respect to this problem. So let's take a look at another problem. The next problem that we have here is y minus 1 quantity squared over 9 minus x plus 1 quantity squared over 16 is equal to 1. Well, I'm going to tell you a couple of things about this. If this was a positive sign in the middle, these denominators would be different, so therefore it would be an ellipse if this was a positive, but it's not, it's a negative. So another thing that I want you to observe is that the y fraction is first and the x fraction is second. You have to be very aware of which fraction is first and which fraction is second. So if the y fraction is first and it's positive, right? Or if the y fraction is positive regardless of the order, then this is going to open up, down. So this one opens up, down. Now here's where you have to be extremely careful. The center. You can't just look at this and say, oh, the center is going to be 1, negative 1, because that's not true. You have to be very clear about where the x is and where the y is. Be very observant. So this is where the x value comes from the center. So it's going to be a -1, and your y value of the center is going to be a +1. So that's where you have to be extremely cautious. You have to understand where your y fraction is and where your x fraction is. I've seen people mess this up too many times because they were not aware of where the y fraction was. So let's plot this. We're going to plot -1, 1. So -1, 1 is here, and this is my center. All right. So now I'm going to take the y. So this is the square root of 9, which is 3. So because this is underneath the y fraction, that means that I'm going to count up 3 and plot a point. 1, 2, 3, plot a point. I'm going to go down 3 and plot a point. 1, 2, 3. Okay? And because the y fraction is positive, these guys are my vertices. Okay? Now let's come over here to the x. The square root of 16 is 4. So I'm going to take my center. I'm going to count right 4. 1, 2, 3, 4. Plot a point. I'm going to count left 4. 1, 2, 3, 4. And I'm going to plot a point. And so these represent the midpoints of my rectangle. So I'm going to draw my rectangle in here. There's a little bit of an art to creating a hyperbola. And now I'm going to take my ruler and I'm going to connect my corners with my center to create my first asymptote. And then I'm going to come in here and again connect the other corners with my center. And there I have my second asymptote. Okay, so let's go after those vertices. So the vertices, let's look at this point. So we have -1, 4. So -1, 4 is going to be one of my vertices. This is -1, 4. And then this vertex is going to be -1, -2. So let's fill in the rest of this. The transverse axis connects my vertices. So this is going to be my transverse axis. I'm going to connect my vertices here. So this is going to be in the y direction. And my conjugate axis is the other. So this is the conjugate axis, which is x. So let's take a look at this. I'm going to actually draw this in here. So this is a little bit wider than the last one was. So I'm just going to come here and kind of skate along this. And come here and just kind of skate along the other one. And then this, the same thing. I'm going to come down here. I'm going to come across here. Like I said, these, it's like an art form when you're creating your hyperbolas. Now the foci. The foci is going to be c squared is equal to a squared plus b squared. So here you're going to have 16 plus 9, and 16 plus 9 is equal to 25. So c is actually equal to 5. So we can actually plot these if we really, really wanted to plot these. And so my first foci is going to be -1. If you count 5, 1, 2, 3, 4, 5. The actual foci is right here. And then this would be -1, 6. So that's my first foci. And then my second foci would be, from the center, we'll count 5. 1, 2, 3, 4, 5. This actually came out quite nice. And so this would be -1, -4. So -1, -4. This is my other foci, -1, -4. Okay, the last thing that we need to do is we need to go after our asymptotes. So your asymptotes, remember, y minus y1 is equal to plus or minus your slope times x minus x1. So as you recall from the last one, the point that both of these share is going to be the center. So we're going to plug the center in for our x and our y. So it's going to make this y minus 1 is equal to plus or minus, we'll fill in the slope in just a little bit, and then this is going to be x plus 1. So we filled in our center, and now let's go after our slope. Our slope is rise over run, so our rise is 1, 2, 3 over 1, 2, 3, 4. So this is going to be plus or minus 3/4. And you can always find this underneath the fractions, right? So the square root of 9 is 3. The square root of 16 is 4. So if you look at this, here's your slope, 3 over 4, right? Your y over x, so 3/4. So that's how you can figure out your slope for your asymptotes without actually drawing the diagram. You can actually see that right within your equation. So now what I want to do is I'm going to separate these so you can see in the last problem I just told you what it was to go to the slope-intercept form, but let's actually do it in this case. So in this case, if we're going to actually go and separate the fractions, this is going to be y minus 1 is equal to 3/4 times x plus 1. And then your other equation is going to be y minus 1 is equal to your negative 3/4 times your x plus 1. Well, if we distribute the 3/4, we're going to have y minus 1 is equal to 3/4 x plus 3/4. And then all we have to do is add 1 to each side. And when we add 1 to each side, we're going to have y is equal to 3/4 x. And then 3/4 plus 1 is going to give us 7/4. So this is what it would be in slope-intercept form. Over here, you would distribute the negative 3/4 and you would have y minus 1 is equal to negative 3/4 x minus 3/4. And then you would add 1 to each side, so you would have y is equal to negative 3/4 x. Negative 3/4 plus 1 will give you plus 1/4. And so this is what it would be in slope-intercept form. And this is what it would be in point slope form. You could keep them together in point slope form. And let's just take a look at this. Let's just inspect this. Well, 1/4, that looks like it crosses basically at 1/4. 7/4 is like 1.75. So this, yes, that looks like it crosses right there. Okay. So if you have any questions, please don't hesitate to email me or show up on my office hours. I have office hours today at 1. So I hope you're all well and safe, and I hope you all have a great day. Bye.